Today we are going to discuss a very important arithmetic topic called mixtures and allegations. First, I'll discuss the basics of mixtures and allegations, and after going through this tutorial, I hope that you should be able to solve any mixtures and allegation problem quite easily. So, how does a typical mixtures and allegation problem look like? In a typical mixtures and allegation problem, we have we mix different types of mixtures to obtain a third kind of mixture. So in this case, we are mixing pure milk and 1 liter of pure orange juice. When we are mixing 1 liter of each quantities, we will get a 2-liter quantity containing 1 liter milk and 1 liter orange juice. That is 50% of milk and 50% of orange juice. So we'll call this solution as 50% milk solution. So all of your questions that you will be handling with mixtures and allegation will come in some or the other form of this kind of scenarios where you are mixing multiple mixtures. A typical solution for a mixture and allegation problem looks like this. Here, here we denote our mixture 1 and mixture B, mixture A and mixture B. So in this scenario, mixture A is pure milk and mixture A is pure juice. Mixture A has 100% concentration of milk and mixture B has 0% milk concentration. So here we'll denote the concentration. Then we'll denote the how much quantity of each of these two mixtures we are mixing. So 1 liter of this and 1 liter of this. So this is quantity that we are going to mix. And this is our resultant. This is our resultant mixture. In this case, we are mixing 1 liter of 100% milk and 1 liter of 0% milk. So we will get 50% milk solution. So first things first, before attacking such kinds of problems, you'll need to have a good idea of or good understanding of these two basic concepts. So first concept is of that of weighted average, and the second is of concentration, a basic idea of the concentration. So we'll do a quick recap on both of these two concepts, and then we'll move on with problem solving on mixtures and allegations. So please hang on. To understand weighted average concept, consider the scenario where you have given an entrance examination. That entrance examination consists of two phases. First phase is interview, and first phase is written examination, written. Second phase is interview. So you score some marks in written examination, you score some marks in interview examination. First, this is given as 80% weightage, and this score of yours is given as 20% weightage. So how will you calculate your final value? So to calculate the final value, you multiply you will do a multiplication of with the factor 80. That is, you'll multiply with the weight, corresponding weight. Exam score has weight of 80, and interview score has the weightage of 20. And then you will distribute it over the total weight 100 to get the average score. Consider another scenario where you have a very cheap quality rice, rupees 10 per kg, and a very high quality rice, rupees 50 per kg. When you're mixing these two quality of rice, you will get another rice. See, here you are mixing 1000 kg of this and 10 kg of this. So you will get 1010 kg of rice, which will still be of cheaper quality because you have mixed more of cheaper quality rice, right? 1000 kg of this rice plus very chunks of small bits of high quality rice. So you'll get this. So how to calculate the exact price that this rice will be worth of? So we have different weights, right? 10 kg have different weight and 50 kg has different weight. So we'll apply the same concept. With 10 kg rice and with 50 kg rice, we multiply with their respective weights. 1000 here and 10 for the second quality. And we average it out on the total weight. Total weight is 1000 plus 10. So we got rupees 10.396. So this mixture or this rice is again of a cheaper quality, not uh, quite as good a quality as this 50 rupees 50 per kg. It's close to this, because we have added only few droplets of high quality rice. This doesn't make our rice of very high quality. So that's how we got 10.396. But I hope you understood the basic concept of how to calculate weighted average. That is, we will be given weights and we will be given the values. So we'll multiply weights and values for all those weight 1 and value. This is weight 1 and value 1 and weight 2 and value 2. So we will multiply this. We'll get total value and we'll average it out the total, right? So this is how weighted average questions will be solved. We will be solving. The second concept is of concentration. What do we mean when we say we have a 80% water solution? When we say that we have a 80% water solution, we mean that in a jar we have 80% water and rest 20% other substance. That is, out of 100, 80 is water. When we cancel it out, we'll get 4 by 5. That is, out of every 5 liters, out of every 5 liters, we have 4 liters and 1 liter, 4 liters of water and 1 liter of some other substance, right? That is, when we say 80 out of 100 is water, we mean 20 out of 100 other substance. When we say 4 by 5 is out of water, 4 out of 5 is water, we also mean 1 out of 5 is other substance, right? When out of 5, 4 is water, 1 is some other substance. What do we mean when we say 100% water solution? A 100% water solution will have no other substance. That is, 1 out of 1 is water. That is, out of 1, 1 is water. What do we mean when we say 3:2 milk and water solution? When we say we have a 3:2 milk and water solution, so we have 3 milk and 2 water. That is, out of every 5 liters, we have 3 milk solution, or 3 by 5 milk concentration, or 2 by 5 water concentration solution. So we can represent solution in terms of milk. Then we will say 3 by 5 milk solution it is. And when we want to represent the solution in terms of water content in it, we'll say 2 by 5 water solution it is, right? These two ways. So let us try to understand this question and solve this. So we have a 3-liter grape juice containing 2 by 3 water. So we have a 3-liter grape juice. So this is 3-liter grape juice containing 2 by 3 water. So 2 by 3 out of 3 is water and 2 by 3 water. So this is grape juice solution, right? So if there's 2 by 3 water, rest would be juice. How much juice? So 1 out of 3 is juice. That is, out of 3 liters, 2 is water and 1 is juice, right? Sorry. Uh, so we have this A and we are mixing with a solution B, which is a 2-liter solution containing 3 by 8 water. So when we have 3 by 8 water, how much would be juice? We'll have 5 out of 8 as juice, right? Whenever we say we have 3 out of 8 is water, so if this is 8 liter, 3 is water and rest 5 would be juice, right? So in this scenario we are mixing these two, A and B, right? So we are mixing A and B. So so here we have solutions that we are going to mix, the quantities will denote here, and the resultant, right? So this solution, the first solution have concentration as 2 by 3, right? 2 by 3 water concentration. So this is with respect to water. And 3 by 8 second has 3 by 8 water concentration. The first will has quantity 3 and the second has quantity of 2 liters. So when we are mixing 3 liters of this concentration and 2 liters of 3 by 8 concentration, what we'll get? We will get 2 by 3 into 3, right? This concentration multiplied by its weight. And how much this concentration has it in it? 3 out of 8 times 2. What is the total concentration? 3 plus 2, 5. then we will get 11 out of 20. This is equal to 11 out of 20, right? So this is now remember, just note here that these we are representing, this what we are representing here in red circles are water. That is water out of total. We are representing like this, water out of total. So here also we got water out of total. Now, if you see, the question here is what percentage of the new solution is juice? It's not asking what percentage of new solution is water. It is asking what percentage of new solution is juice. That is, if we have 20 liters, resultant 11 is water. So rest would be juice, right? To answer our question, we'll need this value. That is 9 out of 20 is water. So we have 45% juice, right? Sorry. Okay. So we have 45% as juice. So this we have solved with respect to water content. So we got here water content. What if we wanted to solve it directly with juice content? So we would have got here juice content. So again, we will have here two mixtures, A mixture and B mixture that we are mixing. So we'll see what is the juice content in the A mixture and what is the juice content in the mixture B. The A mixture has 2 by 3 water. Again, according to the question, the A mixture is 2 by 3 water and the B mixture is 3 by 8 water. So what would be the juice? If 2 out of 3, 2 out of 3 is water, so 1 out of 3 would be juice, right? So here we have 1 by 3 and the mixture B has 3 out of 8 water. So out of every 8 liters, 3 is water. Out of every 8 units, 3 units is water. So how much would be juice? Rest 5 would be juice. So here 5 rest 5 would be juice. What is the content that we are mixing? Here the quantities are 3 liters of the first kind and 2 liters of the second kind. That is what we are mixing here. To solve this, we'll have 1 by 3 into 3 plus 5 by 8 into 2 divided by 3 plus 2. That will get 9 by 20. Right? So if you see here, right, 1 by 3 and 5 by 8. When we say 2 by 3 water, we meant 1 by, if 2 out of 3 is water, the rest 1 out of this total would be juice. If 3 by 8 is water, when we are seeing it with respect to juice content, rest 5 out of total is juice. The content 3 liters and 2 liters that we are mixing here, we get 9 by 20. So here what we have found is juice out of total. So 9 liters juice out of total. What is the percentage? Again 45%. That is what we have got here. Question 2. A 3:2 milk and water solution. So this is our first solution and is mixed with another 4:1 milk and water solution. So this is our second solution. So what we are mixing here? Let us see with respect to milk. So 3 out of 5 is milk, right? 3:2 milk. That is 3:2 milk and water, right? 3 milk and 2 water. So every 5 has 3 milk. So 3 out of total is milk. So we have mixture A, we have mixture B. The concentration of mixture B is 4 out of 5 milk. What is the weights, the quantities? The quantities are 400 liters of this concentration and 1000 liters of this concentration. When we mix these two, what is the concentration value we'll get as a resultant? 3 by 5 into 400 plus 4 by 5 into 1000 divided by 1400, right? Total, we'll average it out of the total. So that will get 3 by 5 with respect to milk that we're solving, 26 out of 35. That is every 35 liters has 26 liter water, sorry, 26 liter milk. How much would be the water? 9 liters water. Rest 9 will be water, right? 26 milk by total. So this is what here also milk by total we have seen, right? Milk by total, milk by total. This was mixture A and this was mixture B. And so 3 is to 2 milk and water meant 3 by 5. So what if we want to solve it with respect to water content in it? In that case, what we will get here is we'll get how much water out of total we have. For that, here we'll have to write water out of total and mixture B also water out of total. So in this, how much water out of total? We have 3 milk and 2 water, right? So 2 water, 2 out of how much? 2 out of 3 plus 2, 2 out of 5 water. And in this case, how much water we have? 1 water, right? 1 out of 5 water. So 2 by 5 and 1 by 5. 2 by 5 and 1 by 5. And what is the weights? We have 400 and 1000. So so how do we calculate? So 2 by 5 concentration times its weight plus 1 by 5 concentration times its weight divided by total weight. This we will get as 9 by 35, which will mean out of every 35 liters, we have 9 water and rest 26 milk. And what is that we have to find? We have to find what is the ratio of milk to water. That is, milk is to water. The ratio of milk is to water is not 26 by is to 9. Sorry, is not 26 by 35. That is, if we write 26 by 35, that is milk by total. What is milk by water? It is 26 is to 9. So in both the cases, we got 26 by 9. Answer is 26 by 9. There's different variation of mixture and alligation problem that you might encounter at various places. In this particular um, type of variation, we are given the concentrations A and concentration B, and we have to find, and we are also given the final concentration of C, the result mixture. So the question might ask us what is the ratio in which we have mixed A and B to get C concentration or Z concentration, a mixture of Z concentration. To help solve this, we have this rule of alligation present with us. What does rule of alligation say? Rule of alligation rule of allegations gives a say, and rule of alligation describes that this value, that is the ratio in which the two concentration is mixed, is nothing but the deviation of the concentration from the final mixture that we have got. That is, what would be the deviation here? Z minus x, right? And here z y minus z, z minus x and y minus z. This should be z. Sorry for this. This should be y minus z. So just remember this rule. We are given a, b, and c. This is nothing but the difference from here and from here. This is the ratio in which we would have mixed x and y. To understand this better, let us take a problem. We are given A and B both with concentration 10% and 20% to get a concentration C of 15%. So what would be the ratio in which we have mixed A and B to get 15% concentration? So according to rule of alligation, we know that this is nothing but the deviation from this side and deviation till here. So 15 minus 10 is 5 and 20 minus 5, 15 is 5. That is 1, 5, 5 cancel, 1 is to 1 ratio. So A is to B, we are mixed with a ratio of 1 is to 1. That is also quite evident, right? We have from 10% to 20%, we are getting 15% according to the question, right? So we would have mixed equal quantities of both, right? Equal quantities of both. So let us solve a problem. Sorry. Continue recording. So let us solve a mixtures and alligation problem based on rule of alligation. The question is, a milkman mixes 70% of milk solution. So he mixes a solution which is 70% milk. So concentration and this is solution A, and this is solution B. So concentration of milk is 70%. Concentration of B. So what are the two mixtures? First is a 70% milk solution with water. So B is water. This is water. So what would be the milk concentration in water? Zero, right? Very obviously, zero. To obtain 60% milk solution, so this is 60% milk solution. Find the ratio in which the two have been mixed. So what would be the ratio in which we have mixed? This is we have to find. So this is 70 minus 60 equal to 10, and this is 60 minus 0 equal to 60. The answer would be 6 is to 1. We can also solve this by considering, here we had solved this using considering with respect to milk, right? We could also solve this with respect to water, that is considering water as a solute, or considering the solution as a water solution. So we will say this as water solution. So we are mixing two solutions, A and B, right? First solution has what concentration of water? Since it is 70% milk solution, means rest 30% would be water. Second solution is pure water solution. So what is the concentration of water in a pure water solution? It will be 100%, right? 30% and 100% we mixed, and we are getting 60% milk solution. That is to say 40% water solution. So we have to find this. So this is nothing but the deviation. 10% here and 60 here. Again, 6 is to 1. So we arrived at the same answer. We can also solve this thing using fractions or parts. When we say 70% milk solution, we mean that 70 out of 100 is milk. That is 7 by 10 is milk. And we are mixing it. What is the solution be? Water. So what is the milk concentration in water? 0 out of 1. So milk is 0 out of 1. So and what is that we are getting when we are mixing this? We are getting 60% milk. That is 60 out of 100 is milk. We are cancelling 6 by 10 is milk. So we have to find these two values, the ratios. To find that, we'll apply the rule of alligation. 7 minus 10 minus 7 by 10 minus 6 by 10. And here 6 by 10 minus 0. That is 6 by 10 is to 1 by 10. We'll cancel this. We'll get 6 by 10 as the answer. So we will discuss some trickier problems in our next video. I hope that you enjoyed this video and understood the basic concepts of mixtures and alligation. Please see my next video to deal with some tougher problems. Thank you.